Okay, good morning. So today we are going to continue with our lesson on finding the perimeter and area of two-dimensional figures. And the same thing, the objective for this lesson is of course finding the area and perimeter of plane figures. And this time we're going to discuss the ones that we have not covered in the first installment. We're going to discuss on how to find perimeter and area of parallelogram, rhombus, trapezium, and finding the circumference and area of the circle. Okay, so let us have the parallelogram. Parallelogram, if you would like to find the perimeter of it, this is the same as the rectangle. Of course, they are the same as the rectangle, only that in a parallelogram, uh, no angle is a right angle. So we have a pair of acute angles and a pair of obtuse angles. So the sides are slanting, that's why the angles are not right angles. But the formula of finding the perimeter is just the same as with the rectangle. It's twice the sum of the adjacent sides. And to find for its area, the same as length times width, this is also this, and the formula is also base times height. So the measure of the base times the measure of the height. And the height is the perpendicular distance of uh, the sides which are parallel. And those sides are base 1 and the base 2. Okay, so let us have this example. The base of the parallelogram is thrice its height. So we are not given the measures of the base and the height, but we're given the conditions that the base is 3 times its height. So we can assume that the height is an unknown x and the base is 3x because it's thrice its height. And we're given the area which is 192 square centimeters, and we are asked to find the dimensions of the base and the height. So from the formula, area equals parallelogram of the parallelogram equals base times height. So we have 192 equals 3x times x, or by symmetric property of equality, it is, we can say that 3x squared equals 192. And the golden rule in algebra is that if you do some manipulations on the left, you will also do it on the right. So we will divide both sides by 3 to eliminate the constant 3. So we have x squared equals 64. And finding the square root of 64, it is x is equal to 8. And we know that x is the height. So the height is 8. And therefore, the base is 3 times the height is 24. You can also check 24 times 8 and you will find that it is equal to 192, which is the area. So very easy. Now we have the rhombus. So the rhombus, if you find the area of the rhombus, it's also the same as base times height. Or we can have the formula 1/2 the length of one diagonal times the length of the other diagonal. So 1/2 L1 times 1/2 D1 times D2. And the perimeter, just like a square, you will multiply the measure of one side by 4. Example, if the lengths of the diagonals of a rhombus are 16 and 30, so this time we're given D1 and D2, 16 and 30, and you are asked to find its area. So area is 1/2 the product of D1 and D2 is 1/2 of 16 times 30, or 1/2 of 8, so that is 240. So it's easier. You can multiply 16 times 30 and divide it by 2. You will get the same 240. So the area of the rhombus is 240 square centimeters. Now let's have the trapezium, or others call this one as a trapezoid. In the US, it's called trapezium. Okay, so 1/2, the formula for the area is uh, 1/2 sum of the parallel sides times the perpendicular distance between them. Okay, so or that is 1/2 of P1 plus P2 times the height, where P1 and P2 are the parallel sides. Okay, example, so a line connects the midpoint of BC, and you have there the point E, with point D in the square ABCD. Okay, so calculate the area of the acquired trapezoidal shape if the trapezoidal shape of the square has a side of 4 meters. Okay, so remember that there is a line that connects the midpoint of BC, okay, to the point D. So if we are going to illustrate it, it looks like this. So we have a square ABCD, and the midpoint of BC is point D. So meaning to say the midpoint is 2 meters if the side is 4, and if it is a midpoint, it divides exactly by the line into 2 congruent parts. So that's 2 meters, and this point here connects here. So now what is formed is a trapezoid. So you are going to find for the area. So that's 1/2 P1 plus P2 times the height. So P1 is 4, P2 is 2 times the height. This is 4. So 4 plus 2 times 4. And since it is 1/2, so divide by 2. So 4, that's 6 times 4, 24. Divided by 2, that is equal to 12. Illustration, this is the shape given 128 meters on base 1 and or the P1, and then we have this P2 which is 92. Okay, but then there is a walkway that you will subtract. Okay, so that is 128 plus 92 times 40, the height, divided by 2 minus 40 times 4, this walkway, which becomes a rectangle. So that is the final area of this wooded part is 4,240. The wooded part only minus this walkway, because this walkway has no woods in it. Okay, so now let's move on to the, I think we are done with those figures, basic plane figures. Now let's move on to the circle. Okay, so if you would like to find for the circumference of the circle, the formula is 2 pi r, or if that is if you're given the radius, and it is pi d if you're given the diameter. You may substitute pi with 3.14 or 3.1416, or you can have the non-repeat this fraction 22/7. But I would rather, if you are going to solve now on your own, I would rather have you retain the pi. Do not substitute the value, but for the sake of examples, I'm going to substitute pi with 3.14, and the area is pi r squared, or this is pi d squared over 4. And if you would like to find the area of the ring, that is area of the outer circle minus the area of the inner circle. That is if you're asked to find for the ring. Okay, so let us have example. The diameter of a nickel is 2 cm. What is its circumference? So you're given the diameter 2. So if you are going to find for the diameter, circumference as pi d, or that is 2 pi, or basically if you substitute pi with 3.14, that is 6.28. Okay, the circumference of a bicycle wheel is 50.24. Okay, so what is its diameter? So you're given now the circumference, okay, of the wheel which is 50.24. Then you are asked to find for the diameter. So from the formula, pi d, okay, so circumference is 50.24. So d is circumference over pi. So that's 50.24 over 3.14, or that is 16. You may also check with that and using your calculator if the calculation is correct. Another example, the circumference of a compact disc is 28.26 centimeters. What is its radius? So if you're given the radius, the formula of finding the circumference is 2 pi r. So circumference is 2.26. Then you're asked to find for the you may use the formula pi d because that's easier. Okay, so d is circumference over pi, so 28.26 over 3.14. So your d is 9, and we know that d is twice the r, so d is divided by 2, so you have the r, which is 4.5 cm. Okay, another example. The diameter of a bicycle wheel is 25 inches. So how far will you move in one turn of your wheel? So 25 inches, and circumference is pi d. So circumference is 78.5 inches. So that's how you will move your wheel in one turn. That's 78.5 inches. Okay, so I think this is the second to the last example. Find the area of a circle with a radius of 3.5 cm. You are told not to round your answer. Okay, so you will round it off, in 3 decimal places. So given the radius r, which is 3.5 cm, area equals pi r squared. Pi is 3.14 times r squared, 3.5 times 3.5. So area is 12.25 pi centimeters squared, or that is 38.465 centimeters squared. Okay, so here, if the diameter of a circle is 9 cm, then what is its area? Again, do not round your answer to 2 decimal places, but instead 3 decimal places. So if you want to make it easier, area is pi r squared. And given the diameter, you will divide the diameter by 2, so you have your radius as 4.5 cm. So area is pi r squared, that's 4.5 squared times pi, 3.14, or that is equal to 63.585 centimeters squared. And you will continue answering pages 14 to 19 and 35 to 40. Okay, so I think that's all for the second installment. So by next meeting, the next video that I will upload is going to be on volumes of solids.